Welcome back everyone. In this section, we are going to look into application lifecycle management. In the previous section, we have learned the different components of Hyperledger Fabric and how those different components come together and form a Hyperledger Fabric network. Since we have a good understanding of how Hyperledger components work and how they form a Hyperledger Fabric network, we are ready to go and understand the application lifecycle management. In this section, we are going to look into how to install and instantiate Chaincode package, how to configure endorsement policy, and how to define collection policy for private data, and how to modify or upgrade Chaincode. Coming to the first part, which is install and instantiate Chaincode package. As we know, we can write multiple smart contracts, and all those multiple smart contracts are bundled into a chain code, and we have to install and instantiate on our network. So now let us get into the two commands which are used to installing and instantiating chain code on the Hyperledger Fabric network. Let us see the first command, which is pure chaincode install command. So as you can see in this command, pure chaincode install, you have -n, which says the name of the chain code, and -v is the version of the chain code that has to be installed, which we have specified as v0, which is version 0, and -p is the path of the chain code. So this is the command that is used to install the chain code on the network. Moving on to pure chain code instantiate. So this is the command that is used to instantiate the chain code on the network. Now let us understand the meaning of all these arguments that we are passing. Pure chain code instantiate, then you have -o orderer. This, this -o option tells the ordering service endpoint. So what do you mean by endpoint? Endpoint is nothing but a place where that orderer service is running. Then you have -c my channel. This tells the channel ID. So this is the channel on which this command should be executed. Then you have -n, which is the name of the chain code. Then again you have -v, which is the version of the chain code that we have already mentioned in the chain code install command. Then you have -c, which represents the constructor message for chain code in JSON format. As you can see, when you take an account from this brace to this curly brace, this is a JSON format. The default is an empty close and opening and closing parenthesis, which provides no arguments at all. So, but here we are providing different parameters. As you can see here, we are providing arguments, which is an array, and it contains different parameters, which are nothing but the name of the function that we are calling and the parameters that we are going to pass to that function. And you have CA file, and this is a path file which contains the PEM file. So this is the PEM file is nothing but the encoded trusted certificate for ordering endpoints. And you have the last option, which is TLS, which means you have to use the TLS when communicating to the orderer endpoint. So there are other options as well. You can visit the documentation of Hyperledger Fabric if you want to use or if you want to know some more options that are available in the for all these particular commands. So moving on to endorsement policy. How do you configure endorsement policy? So by default, endorsement policies are specified in the chain code definition, which is agreed to by channel members and then committed to a channel. That is, one endorsement policy covers all of the state associated with the chain code. So we have to configure that in config.tx.yaml file. Although we have already mentioned or we have already learned about the config.tx file, I want to show you how and where this organization and application comes in that particular config.tx file, and we will look into it right now. Let us go to the code. So as you can see, this is the config.tx.yaml file which we can see here. So we have different section over here which you can see. So in this you have organization section. As you can see here, for each organization which is part of the network, you are defining different policies. As you can see, you have orderer and you have organization 1, you have organization 2, you have organization 3. For each of the organization, you are defining different policies. Here we are choosing signature policy. As we have learned in the previous section, we have different types of policy. One is the signature policy and implicit meta policy. In here we are choosing signature policy, and the same goes for the other three organization as well. As you can see here, you have different types of policies that you have to define for that particular organization, and same goes to organization 2 and organization 3 as well. So this section includes the policies for organization. So you also have policies for applications as well. As you can see here, you have defined policies for application, and in this we are going for implicit meta policy. So that is it about how you are configuring the policies. Now let moving on to where we have left from. So this is how we are going to configure in the config.tx.yaml for both organization and application. Moving on, so that is one way of configuring endorsement policy, which we have seen in config.tx.yaml file. There is another way of specifying an endorsement policy for the and that is using the Fabric SDK. So you can also create an endorsement policy from your command line interface when you approve and commit a chain code definition with the Fabric peer binaries using dash dash signature dash policy flag. So we are going to see the command in detail. Now, as we already know, we have to go through different stages when we have to install and instantiate the chain code. As part of this, when we are trying to approve for a particular organization, which is this command that we are executing. So at this point of time also, we can set the endorsement policy, which you can see here, signature dash policy, and we are setting the endorsement policy over here. So this command means uh, it approves the chain code definition of my CC with the policy and which is which is defined here, and which could require that both members of organization 1 and organization 2 should sign the transaction. With why it is needed, both of these members are needed, it's because we are mentioning the expression as and. To make this command clear, I am gonna go and show it in VS Code so that you will get a clear picture of how this command looks like. So this first one is the command that we are talking here. So peer lifecycle chain code approve for my organization. Sorry, approve for my org. So here you are specifying the channel ID. Here in the third option, which is signature policy, you are specifying that both organization 1 and organization 2 member have to sign this transaction. So this is how it looks like, and here you are specifying the name, version, package ID. You are also specifying sequence. You are mentioning to use the TLS, and this is the CA file, which is the PEM file, and this is how the command looks like. And this is where this flag is where you are going to set the endorsement policy. Moving on to the next slide. So this is one more command, which is the command to commit the chain code. So In this command, which you can see, this means what this command is doing is, after a sufficient number of channel members approve a chain code definition for my CC, the definition and endorsement policy can be committed to the channel using this command. Now, let us go to VS Code again and see how this command looks like. So, this is the command, which is peer lifecycle chain code commit command. As you can see over here, you have signature policy and organization 1 member and organization 2 member. So rest of the commands, or sorry, rest of the option remains the same as with the first command which we have explained. The difference is here you are mentioning the peer address and also the certificates for both the members, which has to sign in this, as we already mentioned in the signature policy. As you can see, the member of organization 1 and member of organization 2 has to sign the transaction. So as part of member of organization 1, we have peer 0 or .org1.example.com, which is running at port 7051. And you, for as part of organization 2 member, we have peer0.org2.example.com, which is running on 9051 port. So both of this has to sign this transaction. So this is how endorsement policy can be included in peer lifecycle chain code commit. Now let us go back to the presentation. Now we know that there is something called private data. So in order to refresh your memory, I'm just going to give a brief about what private data is. So private data brings the concept of data privacy among multiple participants without creating a separate channel for each other. If you want to go with Hyperledger Fabric documentation, it says in cases where a group of organization on a channel needs to keep data private from other organization on that channel, they have the option to create a new channel comprising just the organization who needs to access the data. However, creating separate channel in each of these cases creates additional administrative overhead, which are nothing but maintaining chain code versions, policies, MSPs, etc. And that doesn't allow for use cases in which you want all channel participants to see a transaction while keeping a portion of the data private. So this is where data private collection or private data collection comes into picture. So how we going to specify the policies for this private data? Let us look into that. So for private data collection, you can also specify an endorsement policy at the private data collection level, which would override the chain code level endorsement policy for any keys in the private data collection, thereby further restricting which organization can write to a private data collection. Similar to chain code level endorsement policies, which we have seen in the previous section or previous slide, when you approve and commit a chain code definition, you can also specify the chain code's private data collection and corresponding collection level endorsement policies. If a collection level endorsement policy is set, the transactions that write to a private data collection key will require that the specified organization peers have endorsed the transaction. Now, you can see how the data that is present as part of the collection, which is a private data. So we can also um, write, or we can also configure the endorsement policies for collection level data. So you can use this collection level endorsement policy to restrict which organization peers can write to private data collection key namespace. For example, in order to ensure that non-authorized organization cannot write to a collection, and you have a confidence that any state in a private data collection has to be endorsed by the required collection organization. So if you're not understanding what this private data collection is, I recommend you to go through a use case or a fabric documentation which is already available. I'm going to tell you the link as well. So before that, the one more point to mention is the syntax for collection level endorsement policies exactly matches with the syntax for chain code level endorsement policy. But the difference is in the collection configuration, you can specify an endorsement policy with either a signature policy or channel config policy. I'll explain you in detail and I'll also give you the documentation where this is explained with an example in Hyperledger Fabric documentation. So this is how it looks like. So it defines the collection policy for private data. So now let me go to that link which has this. So this is the link which says this gives the sample connection definition JSON file. This contains array which contains the collection definition. As you can see, you have only this that we have mentioned, which is this part. So this is the use case for a marble use case, which is there in the Hyperledger Fabric documentation. If you follow that use case, you can see here the collection marble private detail definition restrict access to subset of organization in the channel, which is it is restricting only to organization 1, which you can see here, right? So additionally, writing to this collection requires endorsement from an organization 1 peer, even though chain code level endorsement may require endorsement from organization 1 and organization 2. As we have seen during the chain code installation and instantiation, so we have given endorsement policy as either organization 1 or organization 2 has to approve that transaction. But when it comes to this private collection, here we are specifying only organization 1 has to approve for this private collection data. So here, so the reason why the reason is since you have only organization 1 to approve to, so that is why the member only right is set to true, which means only client from organization 1 may invoke the chain code that writes to private collection. Please go through this use case so that you will understand what this private data collection is. And you can also write your own custom collections and your own custom policies as well. Moving on to the PPT. Now, how you are going to modify or upgrade the chain code? So it is as simple as that, as simple as the installation and the instantiation or the chain code starting that we have done during the previous slides that I have explained. So it is the same process that you have to follow in order to upgrade or modify the chain code. So that is it for this session. And in the follow-up session, we are going to go into much more detail about the Hyperledger Fabric network configuration. That is it for this lecture. And we also have a private tutoring session for many courses, including this courses as well. Please subscribe to private coaching session to get in-deep one-to-one coaching sessions. Thank you for watching. I'll see you in the next section.